Hey everyone, and welcome to The Explainer. I am so thrilled to have you here with us today. We are about to jump into a seriously fascinating journey into the surprising history of immunity. Now, when most of us think about health and medicine, we could take a lot of concepts for granted. But the way we understand our own biology has actually evolved drastically over the centuries. Today, we're going to deconstruct a concept you've likely believed your entire life. We are looking at the history of immunity, and we'll see how our understanding of it has shifted from ancient philosophy to a literal battlefield, and then to something far, far more complex. So this raises a really fascinating question right off the bat. Is immunity really just a war? Think back to the global trauma we all shared during the COVID-19 pandemic. For years, we were just bombarded with news about how a constantly mutating virus was attacking humanity. Medical professionals in hazmat suits were painted as frontline soldiers, right? We watched daily casualty counts. We huddled in our homes almost like refugees in a war zone. And this shared experience deeply reinforced an idea that most of us learned way back in high school biology, that our immune system is a literal battlefield. But is that actually accurate? Let's take a closer look at exactly where this metaphor comes from. Okay, let's dive into this modern warfare metaphor. It's been so deeply ingrained into our minds by media and education. We look at the human body as this heavily fortified fortress. We see viruses and bacteria as invading armies trying to breach the walls. Our white blood cells, well, those are the defending soldiers. And when you get a fever or swelling, that inflammation is just the chaotic battlefield where the two sides clash. It's constantly pitched to us as a war without gunfire. And, it's a very simple, compelling narrative for explaining infectious diseases to the general public. But as you'll see, stripping down a brilliantly complex biological system into a simple game of us versus them actually required scientists to ignore a lot of really important exceptions. To really understand why this war metaphor has flaws, we need to guide you back in time to show how the concept of the human body actually evolved. Let's trace this back. In the 5th century BC, Hippocrates introduced the foundational ideas of Western medicine, and those were later systematized by Galen in the 2nd century AD. Now, for thousands of years, medicine was deeply philosophical and naturalistic. But then, fast forward to the 19th century, a French physiologist named Claude Bernard sparked a massive biological revolution, and this completely changed the way we view our own existence. Think about this massive paradigm shift. For 2 millennia, under ancient medicine, humans were viewed as a microcosm of nature. Everything was connected. The ancient Greeks believed the universe was made of 4 elements: water, fire, earth, and air. And they thought the human body was made of 4 corresponding humors. So health literally meant you were in perfect harmony with the environment. If the weather changed or you breathed bad air, your humors got out of whack and you got sick. But then, Claude Bernard steps onto the scene in the 19th century and essentially declares human independence from nature. He argued that the human body is an autonomous organism, totally separated from its environment. We aren't just reacting to the wind and the rain, we have internal boundaries that actively block out external stimuli. The human body is an isolated, independent entity. This was an absolutely radical, revolutionary idea at the time.
Bernard actually coined a very specific term for this. He called it the milieu intérieur, or the internal environment. Look at this definition here. He proposed that there is an independent space inside the human body, surrounded and protected by blood and body fluids, where all life systems operate completely autonomously. It's this protective wall of fluids that separates the inside from the outside. And so the absolutely crucial point here is that this exact concept laid the theoretical groundwork for the biological idea of a self. Because think about it. Before you can have an immune system that protects the self, you first have to scientifically define that a self actually exists separate from the rest of the world.
So once we had a defined biological self, it really didn't take long for science to find the villain. In the 1870s, 2 great scientific rivals, Louis Pasteur in France and Robert Koch in Germany, managed to actually culture bacteria from diseased tissue. This led directly to the establishment of the germ theory of disease. Suddenly, the biological non-self was officially identified. If Claude Bernard gave us the concept of a self that needed protecting, well, Pasteur and Koch gave that invader a face. They proved once and for all that tiny microscopic organisms could invade the body and cause illness. Now you can probably guess what happened next. This discovery sent a wave of absolute panic through the scientific community. It led to a truly terrifying question. If invisible bacteria are attacking us, how does the body detect and fight them? Imagine how terrifying this was for 19th century scientists. They suddenly realized there were invisible killers floating in the air, living on surfaces, entirely capable of breaching our bodies. They knew there absolutely must be some internal defense system because otherwise humanity would have been wiped out ages ago. But they had absolutely no clue what it was or how it worked.
The answer actually came from a really fascinating, unexpected place. In 1884, a Russian zoologist named Elie Mechnikov was working at the Pasteur Institute. He was looking at a transparent starfish larva under a microscope and just decided to pierce it with a tiny rose thorn. What he saw was literally straight out of a microscopic sci-fi movie. Looking through that lens, he observed specific cells swarming and gathering around the thorn. They were actively sensing this foreign object and physically trying to devour it. He named these cells phagocytes, which basically translates to eating cells. This brilliant, simple visual story grounded the entire foundation of cellular immunity. Our bodies had literal physical defenders. But, as often happens in science, Mechnikov's discovery quickly sparked an intense historical rivalry between two very different ideas. On one side, you had Mechnikov and the Pasteur camp championing cellular immunity. They viewed these eating cells, or phagocytes, not so much as soldiers, but actually as cleaners. Yes, they ate foreign bacteria, but they also ate old, dying, or useless cells belonging to the host itself, kind of like a tadpole losing its tail as it turns into a frog. Mechnikov argued this cleaning process contributed to the overall wholeness of the organism. But on the other side, you had the Koch camp in Germany, led by Paul Ehrlich and Emil von Behring. They championed humoral or fluid-based immunity. They discovered that the blood contained specific chemical antibodies that acted exactly like chemical locks and keys. These antibodies strictly and specifically targeted dangerous bacteria and toxins. And crucially, Ehrlich argued that the immune system was so unbelievably precise, it would never attack its own tissue. Now, what's really interesting about this slide is the term Ehrlich coined to defend his theory, horror autotoxicus. It translates to the fear of self-toxicity. Ehrlich stated definitively that the body's immune system is fundamentally, inherently incapable of turning against itself. He argued that if antibodies attack the host's own tissues, it would be a total biological disaster, a self-destruct button that nature would just never allow. And because the scientific community at the time was super obsessed with reductionism, breaking things down into neat, predictable chemical formulas like locks and keys, Ehrlich's highly structured chemical theory won out over Mechnikov's somewhat messy biological cleaning cell theory. Horror autotoxicus became the dominant, unquestioned medical dogma for decades. Science collectively decided that the immune system always knows exactly what to attack, and it never attacks itself. Which brings us to a massive, paradigm-shattering roadblock. Let's move the timeline forward a bit to the 1940s, right around World War II. Doctors were attempting skin grafts and organ transplants to try and save wounded soldiers. But the transplants kept failing. The bodies were actively rejecting the healthy organs. This created a massive, glaring mystery. If our immune system strictly targets invading bacteria and viruses and never attacks human tissue, why do organ transplants fail? A human kidney isn't a bacteria. So why on earth was the body destroying it? Well, the scientist who finally cracked this mystery was an Australian virologist named Frank McFarlane Burnett, and he did it by looking at one of the simplest creatures on Earth, the amoeba. Burnett watched amoebas gobbling up and digesting bacteria, and he asked a beautifully simple question. The bacteria's chemical makeup is remarkably similar to the amoeba's. So why do the amoeba's digestive enzymes perfectly break down the bacteria, but they somehow avoid digesting the amoeba itself? He realized that even the lowestly single-celled organism must have an inherent chemical ability to recognize what is self and what is non-self. And he applied this concept directly to human organ transplants. The body was rejecting the organs because, even though they were human tissue, they were biologically non-self. Building directly on this idea, roughly a decade later, Burnett introduced the clonal selection theory. This is the mechanism where specific white blood cells, called lymphocytes, possess unique receptors. When a foreign antigen, a non-self invader, enters the body, only the specific lymphocyte with the perfectly matching receptor activates. It then multiplies rapidly, creating a massive army of identical clones to fight off that specific invader. Guys, this was brilliant. It literally explained everything that was baffling scientists at the time. It explained immune diversity, how we can fight millions of different bugs. It explained immune memory, why we don't get the same sickness twice, because those cloned cells actually stick around. And it explained how our bodies can mass-produce defenses so incredibly quickly. Burnett neatly tied all of this together into the definitive self-non-self paradigm. He argued that our biological identity isn't just magic, it is actively learned.
During the fetal and early neonatal stages of life, the immune system basically takes an inventory of the body. It learns what is self, and it learns to tolerate it. Anything that is introduced after this developmental window is automatically considered non-self, and it gets attacked. Furthermore, any immune cell created by the body that accidentally has the ability to attack the self is immediately deleted and destroyed before it can do any harm. This beautifully solved the mystery of immune tolerance. And honestly, it made the warfare metaphor seem totally perfect. The immune system is an army that learns exactly who the civilians are and blindly attacks anyone not on the VIP list. So it all seems so neat and tidy, right? The military metaphor totally holds up. We have a self, we protect it, and we destroy the non-self. But I'm going to leave you with a final provocative question. As modern immunology continued to advance well past the 1950s, scientists realized that Burnett's beautiful theory had a massive underlying problem. In the real biological world, where exactly does the self end and the non-self begin? Think about the food you eat, or the beneficial bacteria in your gut. Or what about a fetus growing inside a pregnant mother, which is technically half foreign DNA? Why doesn't the immune system attack them? The biological boundary between us and the outside world is not a thick stone wall. It is actually terrifyingly blurry. The war metaphor might be super easy to understand, but biology, it turns out, isn't always a battlefield. Sometimes it's a negotiation. And we're going to have to explore exactly how that negotiation works next time. Thanks for learning with me today.